And I may stop recording. Um, let's see, how do I make all this go away? There we go. All right, great. Things we've got going on this week. So there's going to be a homework due on Friday. And that'll be on Achieve, which almost all our homeworks will be, if not all, from here on out. And there'll also be a quiz on Friday. All right, if you're looking for kind of help in the class, there are all sorts of options you have available to you. One of which is I'm available today for between 1 and 5, but you need to tell me after class, okay? So get help between 1 and 5 p.m. today, but you need to tell me after class. You can also schedule that 24 hours in advance with Navigate, okay, if you want to do that sort of thing. But if you're thinking in class, I want help today. So it's Mondays and Wednesdays are my days I can do that. Also on Thursday, there'll be a help session. And that's on Google Meet. Okay, and the link for that is in the syllabus. Okay, so Thursday help session at 7 p.m. and I set an alarm on my phone, so that's going to go off, and I will not forget that. Questions on things we've got going on in the class? Okay. All right, then today what we're going to do is we're going to start talking about chemical and physical changes. And then once we're done with that, we're going to go on and talk about unit conversion. Unit conversion is a big deal in chemistry. So let's go ahead and talk about chemical and physical changes. All right, so when we talk about this, we haven't really defined what atoms are, what bonds are, but we talked about how we have these compounds, right, where atoms are stuck together in some way, shape, or form. So in a chemical change, or let's talk about a physical change. Physical change, I'm going to use the word substance, where a substance is either compound or element. Physical change, the substance does not change. All right, so an example of that might be this paper clip here. This paper clip is made of metal. I don't know what alloy it is. So it's probably like iron and tin and something like that. But this is made of metal. Might be some zinc in there. I just bent it around. Was that a chemical or physical change? Physical, because it started out being metal, whatever kind of metal it is, and it ended up being metal, same kind of metal, right? The shape changed. So that's a physical change. What if I bent it so much that I broke it? Chemical or physical change? Still physical change, right? Because I have two pieces, but they both be the same metal I started out with. I'm apparently failing at breaking it, so I'm going to not do that part of the demo. How about this rubber band? I'll take this rubber band and stretch it, right? And when I'm done stretching it, it snaps back. Chemical or physical change when I stretch it? Physical, okay? This is made of the same polymer. There's some polymer, right, in here that makes this up. And it's the same polymer when it's stretched as when it's together like this. Okay, so that is a physical change. Another thing that can tell you when you have a physical change is if you stress the system. So in this case, I'm stressing the system. I don't want to shoot it at somebody. But when I stress the system, right, it changes shape. And when I unstress the system, it goes back. So that's also a clue sometimes. Wasn't the case for the paper clip, though, right? I bent the paper clip on a shape, and it stayed out of shape. So not always. We've got these clues, but the substance stayed the same. Let's go ahead and write those two down. So bend or break a paper clip. Okay, stretch a rubber band. All right, here's another one that is going to be a physical change. Okay, you can tell I'm putting them all together. What if I boil water? It looks different, right? Okay, it looks different, but when I boil the water, if I add heat to boil it, right, it becomes steam. If I take away the heat, what happens? It condenses and I get liquid water back, right? If I have it in a closed container, if it floated off into the air, I'm probably not going to see it again. So that is also a physical change. Let me just draw a picture. So I want you to think about what's going on at the molecular level, right? When we think about waters look like these little Mickey Mouses, right? Well, not right. You guys don't, we haven't talked about it much, although you may know from a previous class. So if I have water molecules, they're made of 2 hydrogens and 1 oxygen. And if they're a liquid, they're going to look something like this. Let's say I'm going to just draw maybe 3 of them so we don't spend the whole lecture watching me draw Mickey Mouses. Okay? If I take this and I heat it, so this is water. If I heat it, we've talked about solids, liquids, and gases. How does this change? How does it look different? How would I draw my picture different? Like, let's say I asked you to draw a quiz this Friday. Yeah.
The molecules are further apart.
Yeah, they're further apart. So you heat them, and they spread way out. Okay? They actually spread so far out that there's probably more distance between them than we have in the room. But for our picture, I'm going to draw them farther out, not touching. But so if we turn these into a gas by heating them, they would look like that instead. This is a physical change because the substance is water. It's 2 hydrogens stuck to an oxygen, okay, in terms of the molecule. And after we heat it, it's still 2 hydrogens stuck to an oxygen. And part of your clue there is that if you take away that stress, that heat, that it would turn back into liquid water as long as you didn't let it escape into the air. It would still turn back into liquid water, but just not in a way you could see easily. Chemical change. How do you think the chemical change is going to be different than the physical change in terms of the definition? The substance does change. All right, so let's take some examples of that. So I'm going to see if this example works. Mostly because I was thinking I would do this. I didn't get it prepped in time. Nope, all right, never mind. But if I was to burn this piece of paper towel here, see, you guys missed the chance for me to possibly set off the fire alarms and you wouldn't have to come back to class. But I failed at that. So if I was to burn this piece of paper, what would that be? That would be a chemical change. How would you know that? The paper wouldn't be there anymore. When the heat's away, when it stops burning, it never comes back. Okay? And in fact, actually, I'm not going to draw the equation because we haven't talked about symbols for elements yet. But burning paper. Okay? Actually, I will draw sort of. Okay? So if we looked at what paper looked like, paper is going to be a bunch of molecules that kind of look like this. So a bunch of carbons stuck together.
Okay, and there's more. I'm not going to worry about that. We'll pretend that that's how it looks, with some oxygens on it. Actually, that's an oxygen. And some hydrogens on it. And why I'm drawing this is because I want you to think about how things look at the molecular level, right? You don't have to memorize this one at all. But like that's paper looks something like that. Okay, it's more complex. But when I burn it, what it turns into, and I'm not going to draw all the molecules again, but we get a bunch of these. Bunch of carbons with 2 oxygens stuck to them. Anybody know from something else what that's called? Carbon dioxide, or CO2, right? So we get a bunch of these. I'm going to actually do 6 times those. And we're going to get a bunch of waters. Which they look surprisingly the same, right? I should do the shapes. I'll do the shape of the carbon dioxide better. The shape of the carbon dioxide is actually going to be this. And we'll learn how to do that, but not for a while. Okay, and I'm trying to remember that 6 waters. We're adding hydrogens or oxygens. 1, 2, 3, 4, 5, 6. I'm not going to try and balance it right now. But anyway, so there's going to be a bunch of waters with it too. Okay, questions? So that's an example of that. What about cooking an egg? What would be your clue that cooking an egg is a chemical change? It obviously is because I'm putting it in this category.
When it turns hard, it can't go back.
Right. When it turns hard, so you take an egg and the yolk is liquidy, right? The white is liquidy. If I fry that egg, the yolk kind of stays the same color, but it changes a little bit. It goes solid, and your white becomes opaque. You can't see through it, right? And it actually gets a color, which is white, right? And it doesn't go back when you remove the heat. Also, it looks different, right? Okay? So you have that as a clue as well. Yes?
Are there any examples of chemical changes where you can't really see a difference?
Well, you can think about, so boiling water, chemical changes?
Chemical changes.
Yeah, so you could have chemical changes happening in a solution where you wouldn't be able to tell what was going on. So let's say, trying to think of one where you wouldn't. If you added a small amount of, we'll do acids and bases. So if you had a small amount of acid and base together, you could have those react and neutralize, and you wouldn't see anything. That's one off the top of my head. But there's going to be lots of them. There are lots of reactions that happen in a clear, transparent solution. That the reaction happens, and it's still a clear and transparent solution when you're done. Most reactions that involve an enzyme in your body? Good question. Okay, but I'm not going to give you I'm not going to give you tricky ones if I ask about these. Okay, I'm trying to give you something obvious. Questions before I move on? All right, let's talk about unit conversions. Okay, there are many times in this class, this isn't going to be a definition, but we're going to have to convert from one set of units to another over and over and over again in this class. Okay? When we think about unit conversions and think about these as problems, we're going to start off with some easier problems here, and then we're going to get more word problem-y with more complex things involved. Okay? But unit conversions, there are 2 things I want you to think about. These involve a given, so it's something that's measured, something measured maybe. Not always going to be phrased like that. Or something that can vary. Let's say and or something that can vary. All right, that's one thing we're going to get in unit conversions. And the other thing we're going to get is we're going to get conversion factors, we'll call them. Okay, they don't vary. And you're going to use them as a tool to get your answer. So this thing right here, you're going to start with these. And we'll do lots of examples here. And conversion factors, they don't vary. Tool to get to the answer. And then you can also have, you know, what you're trying to find, okay? All right, so those are the sorts of things. So we're going to start off with some easy examples or some more, let me say, they're not really any easier, but they're going to intuitively make sense because you've encountered them in your daily life and they don't involve science terms that maybe you don't use very often, if that makes sense. Okay, so we'll start with some examples that are kind of commonplace and then we will move to more sciencey sorts of things. So let's talk about making sandwiches. Okay, let's see, I'm vegetarian, so when I make sandwiches, I use one piece of bread, I cut it in half, do a half sandwich. Actually, I'll say 2 pieces of bread because we want to think about what makes a whole sandwich. I use 2 pieces of bread, 3 slices of fake meat. Okay, so this is like tofu meat. And I use 1 slice of cheese. How many? Let's start here. How many? No, let's do how many slices of fake meat do I need to make 5 sandwiches? All right. How many people have already done it in their head? Okay. What? How many? You. Yes. I should know your name because we've talked before. 15. Right? Okay. 5 sandwiches times 3 slices of fake meat. Right? Easy because you've done this in the kitchen probably. Right? This is the sort of thing you might do all the time. Let's break this down though. So if I was to solve this with unit conversion, first let's break down what the pieces are here. What is the given, which is the thing that I'm going to start with that could vary here? Okay, so slices of fake meat is not, you could say as a given it is, but it's a conversion factor actually. Okay, so let's go ahead. We're going to go given. Okay, and conversion factors. And we have multiple conversion factors here. We don't need all of them. So 1 sandwich, I would rethink about this as 1 sandwich equals 3 slices of fake meat. Okay, so that's a conversion factor that's going to help me get to an answer, and I might need it to solve a question. And in fact, this question I do need it. Okay, it's not saying that 1 sandwich, if I had 3 slices of fake meat, then I have a sandwich. But it's saying to make a sandwich, I'm gonna need 3 slices of fake meat. Does that make sense? So how about, what would be the given, what would I start with here then? 5 sandwiches, right. Five sandwiches. What am I trying to find? Slices of fake meat. Does that make sense? And then I'll show you how we put this together. Whoops. So we have, before I do that though, what are 2 more conversion factors that are in the problem? I don't need them, but they're there.
1 sandwich is 1 slice of cheese.
Yep, 1 sandwich equals 1 slice of cheese, and 1 sandwich equals what?
2 pieces of bread.
2 pieces of bread. 1, 2. Questions on that so far? All right, so looking at this, how would I solve this? I need to get from sandwiches to slices of fake meat. So I'm going to start with sandwiches. And so I'm going to start with 5 sandwiches. I'll just do sand so I don't have to write all sandwiches multiple times. I'm going to start with 5 sandwiches. I would place that over 1. I'll show you why in a second. And I'm going to try to get to slices of fake meat, so I need this conversion factor because it goes straight from sandwich to fake meat, right? And then this equal sign is like this is actually a divide sign. It's like this little divide sign. So what I'm going to do is I'm going to set it up so that one of these is on the top and one of these is on the bottom, such that my sandwiches cancel. This is where we're going to use our units. And so the way I would set this up is I would go and say 3 slices of fake meat, okay, is equal to 1. So I do this like an equal sign, equal to 1 sandwich. All right? And then if you look at this, these are divide signs, these are multiply. So if I've got a sandwich on the top and a sandwich on the bottom for units, I can cancel those units out. So sandwiches on the top and sandwiches on the bottom cancel. My final units are slices of fake meat, right? That's the only units I have left, so I know I've got the right answer here. That's on the top. And so then I would multiply 5 times 3, and I would get, and I divide by 1, and I divide by 1. 5 times 3 is 15, divided by 1 is 15, divided by 1 is 15, yes? And so I would get 15 slices of fake meat. Okay? I expressed that to how many significant figures? That's 2 significant figures, right? But that's okay. My other things are 1 significant figure when you look at them, but they are what kind of thing? They're exact. They're counting numbers, right? I can count 5 sandwiches and not make a mistake there. I can count 3 sandwiches, 3 slices of fake meat, and not make a mistake, okay? The conversion factors you should consider are exact anyway. So, and I can really count 15 slices of fake meat. So this is 2 significant figures, but being I could count that easily without making a mistake, you know, I would count that as being exact as well. If that makes sense. Questions? Okay. Let's have you guys try one. All right, so my daughter has a jewelry making business. She's actually going to have a stand at, she's 13. She's going to have a stand at the Old Salem Days in a couple weekends. So my daughter makes earrings. Each earring, they're all different, but each earring takes one hook, 2 beads, and let's say 3 chained butterflies, or 3 butterflies on chains. How many beads does she need to make let's go ahead and say 3 earrings? All right, so you're probably going to be able to do this in your head, but what I want you to do is we're going to take a couple minutes here, or a minute, and I'm going to walk around, and I want you to set that up. Write it out and set it up. What I definitely want you to do is I want you to practice this unit conversion even when you don't need to right now, because the problems are going to get complex enough to where you need it. I use this when I do things. Okay. So if you're taking notes on your computer, hopefully you have a piece of paper and something to write with as well, or you have a pen that you can use with your computer so you can practice this. We're going to have lots of, if you don't today, it's okay, but we're going to have lots of practice problems in class. And I really encourage you to work them here so we can find out, we can kind of work through our mistakes.
Right, I'm putting the one there, you need to put the one, but you need to make sure this is on top, whatever you start with.
Okay, let's go ahead and look at this one. What's the given?
2 beats.
Okay, so you put it all together into one thing, right? Which is great. But so the given, the 2 beads, right? 2 beads is 1 earring. That's going to be a conversion factor. It's a tool we're going to use to solve the problem. Okay, so that's 1 earring equals 2 beads. Or it could be 2 beads equals 1 earring. It doesn't really matter how you phrase that. All right, I'm not going to go give all the givens up there for this one because we'll just take the one that we need. But then the given is 3 earrings. That's what you start with, right? Whoops. Okay, and what are we trying to solve for? Number of beads. Okay, that's going to, actually this should be, all right, and so hopefully you set up something that looked like this. I've got 3 earrings. All right, I had a question about, do I have to put that thing over 1 all the time? It's a divide sign, so I put over 1 for it to make sense, but you could write it like this. I just want you to make sure you take that given and you put it on top. Okay, because that way that we need it on top for us to cancel our units. And in the book, gosh, I think they don't even do this, right? They just have it straight out. Okay, so if you have something without a divide line, that means it's on top. So it also could be written like this. That's also on top. All right, and then I need my conversion factor, which is 1 earring equals 2 beads, which goes on top. Well, where does the 2 beads go, on the top or the bottom?
Top.
The top. Why?
Because the earrings are cancelled.
Because the earrings have to cancel out, exactly. So we got 2 beads, 1 earring, okay, and that's going to give me 6 beads. Questions on how we did that? Yes?
So what goes under the 3 earrings reduction 1?
You could put a 1 there. You could not put a 1 there. You could write it like this, but you need to remember that where you don't have anything. So this, like this, 2 beads, 1 earring. Okay. You could write it like that. You need to notice that the thing I've circled in green here is on top in terms of canceling things. So here earrings cancel with earrings. Also here earrings cancel with earrings. And my final unit, all I'm left with for units is beads, so I bring beads across. Okay, I think I saw all of you writing that down, so I'm going to scroll this off and I'm going to give you a new type of question using the same kind of setup, right? So I've told you we've given you all the conversion factors for making these earrings. How many earrings can she make with, let's go with 8 butterflies? Okay, and fractional earrings, or include fractional earrings in your answer. So I'm going to walk around and just see how people are doing on that. If you don't remember the butterfly to earring conversion, just ask me, I'll give it to you. It's 3, right? Yes. Yes. Okay, so what we've got here is, so I'm not going to write down all these things again, but what's the given here? What am I going to start with? Yes? 8 butterflies, right. And I'm just going to do 8 butterflies, okay? And I'll do it like this time. I won't even put it over anything, but it's on top, right? Remember that. I've got 8 butterflies times, what's my conversion factor? 1 earring equals 3 butterflies. And where do the butterflies go, on top or the bottom? The bottom, right. So 3 butterflies equals 1 earring, right? And then my butterflies on top cancels with my butterflies on the bottom. And I can multiply that across, and I'm going to get 8/3 earrings, or that would be the same as getting, that's like 2 2/3 earrings. Or you could have put it in your calculator, and you'd have 2.666666667 earrings. Okay? If you did put in your calculator, go ahead and you got a decimal point like that. Actually, you carry all the numbers. Don't worry about it for sig figs. Okay. Give me enough that I can see what it is. I don't want to confuse you with it. The fraction is exact, so just don't worry about the sig figs for that one. Does that make? Don't know if it makes sense for that or not, but I don't want you confused by that. Questions? All right, let's make it a little more like chemistry stuff. All right, so less what we're maybe used to. So anybody know that? What did you guys do in lab this week? I finally got a lab manual. Did you do density at all? Did they tell you the density of lead? Okay, I guess I'll do the density of a substance. I don't have it. I think it's like 11, but I'm not sure. Anyway, the density of a substance is, actually, let's do mercury. I can't help it. I have to look it up. Density of mercury. (13.6). Okay. The density of mercury is 13.6 grams per milliliter. Okay? If I have 5.00 milliliters of mercury, how many grams do I have? Go ahead and try that one. I'm going to let you guys get started, then I'm going to ask for what people think is given. And I'll give you a little more time.
So I would not use all power. It's all your water.
What's the given here? 5 milliliters. I probably should be capitalizing L and milliliters there. You should go, if your lab instructor has an opinion, you should go with whatever your lab instructor's opinion is. I'll go ahead and give you another minute, and then we'll look at it. Yes.
So the given is 5 milliliters, so you're gonna start with 5 milliliters on top. And then that should tell you whether you're 13.6 grams of the block from top, based on how you guys use it. I'll have to work this out, maybe. But thank you for calling later. Feel free to call me if I get more work on it.
Okay, let's go ahead and look at this. So the given we said was 5 milliliters, right? So I start with 5 milliliters, 5.00 milliliters of mercury. Oops, sorry, I'm doing this. There's a style I learned, which isn't the style that's in your book. So I'm going to go ahead. This could be over 1 if you like it. I'll put it over 1 this time to make it obvious. It's on top. So now I've got a conversion factor, which is 13.6 grams equals 1 milliliter. What goes on top? 13.6 grams is equal to 1 milliliter. Milliliters cancels with milliliters, and I'm left with grams, which is what I was looking for, right? Okay, and so then I would take 5 times 13.6, which I'm not going to be able to do in my head. What was that? 16? 68. And I need one more significant figure there. Is it 68.0? Yeah? Okay, great. 68.0 grams. Why do I need 3 significant figures there?
Because there's 3 significant figures and everything else that's the problem.
Because there's 3 significant figures and everything else in the problem. Okay, so, but particularly, this is the thing I measured, right, that I started with, that has it. This also has 3 significant figures, so do that as well. Okay? It's probably not exact, being it's 13.6. Questions? Yes?
Say if like the density of mercury had 2 significant figures, but nothing to do with the fault, the answer.
Then I would use 2, if the density of mercury had 2 significant figures, I would do 2 significant figures and assume that I've rounded there. If it's pieces of sandwiches, it's an exact sort of thing, right? But this 13.6 is probably known to about 14 significant figures, and we've rounded it. Does that make sense? Google also rounded it. Okay, so now let's make it more complicated. And this is where this thing is just magic. Okay, I can do these problems. I didn't actually use this method when I was in college, I'll be honest. I just kind of did stuff in my head, and my professors told me to show more work all the time, and I didn't listen to them unless they took off points, in which case I was annoying. But what I did was, Then I got to graduate school and I was working in lab all the time, and whenever I made a mistake making my calculations, it meant it cost me like weeks of work to figure it out. Things didn't work in lab. I didn't know why. I eventually looked back at my notebook. I saw that I'd made a math error, okay? Really frustrating. So this was something where I was like, oh, if I just spend an extra couple minutes actually writing it out carefully, canceling my units, I won't make mistakes, okay? So this is really, really useful. It will save you mistakes. Don't be me in college, be me in grad school, I guess, or be what my professors wanted me to be in college, which was writing out my work and using units, because it really is worthwhile. So sometimes we're going to have more than one conversion factor in a problem. We're going to need to use more than one conversion factor in a problem. All right, we'll do a density problem again. But before we do that, well, actually, let's do it, and then we can talk about metric conversions. So let's do, what's the density of iron? Oh, actually, let's do density of ethanol. I'm a brewer, right? Maybe I'll talk about it. I think it's 0.7. Oh, it's almost 0.8. So 0.789. Great. Okay. If I have 6.0, let's say I'm measuring volumes. I did milliliters before. Let's have 6.0 grams of pure ethanol. How many milliliters do I have? No, how many liters do I have? Okay. The density of alcohol, of ethanol. Ethanol is drinking alcohol, by the way, if you didn't already know it. Density of ethanol is, we just looked that up, 0.78, was it 6? 6, what was it? 789, thank you. 89 grams per milliliter. Okay? And I'm going to give you another, so we have metric conversions, right? We need to get to liters here, but we have milliliters here in our conversion factor, right? So we're going to need more than one conversion factor here. You might not be given this, okay? I'll probably give you at least on the first test, I'll give you the metric conversion factors. So maybe at the top of the test, it would tell you that 1 liter is equal to 1,000 milliliters. For this particular conversion factor, is it a definition? Is 1,000 milliliters defined as 1 liter, or did somebody measure it? It's defined, okay? So it's defined, so it makes it an exact number, so this is going to affect our significant figures, right? It's written as a 1, it's written as 1,000, they're both one significant figure the way they're written, but they're really infinite significant figures because it's a definition, right? Okay. So we can go ahead and try and do this. I'm going to do this as an example, and then we'll probably do another one of these like this as our that you'll work for the final thing here. What's my given? 6 grams of ethanol, right? So I have 6.0 grams of ethanol. I don't have another substance here, so I won't bother saying anything more than 6 grams. I'll just put that over a 1, or there are multiple ways we've talked about writing that. And now I need to use a conversion factor I'm trying to find what? Liters. How many liters do I have, right? So that's a volume. I need to get to a volume. All right, so what conversion factor do I have here that will get me from a mass, which is grams, to a volume? Even if it's not the volume I want. What was that? Grams per milliliter, right, this. Okay, this will get me between grams, a mass and a volume, or grams to a volume. And actually, I do want the grams one because that's what I've used so far. So I'm going to put 0.789 grams on the bottom because I want the grams to cancel with the grams. And that's going to be 1 milliliter. And then I need to get from milliliters to liters. Okay? And I've got this conversion factor that I looked up at the top of my test, or I had memorized. And that tells me that 1,000 milliliters, I put 1,000 milliliters on the bottom because I want milliliters to cancel with milliliters, and then I'm going to put 1 liter on the top. That make sense? Okay? And then if I look at this, grams cancels with grams, milliliters cancels with milliliters. Okay? And then if I multiply across the top and divide by the bottom, I'll get my answer. How will I put this in my calculator? Well, I'm going to probably ignore the ones don't change anything, right? I once again forgot a calculator. So somebody else will have to do this for me. But the cool thing here is, I started out when I did these and I would multiply across the top and I would divide by the bottom and then I would write both numbers down and divide the two. But you can do it lots faster than that. You can just multiply 6. You don't have to do the times ones, but 6 times 1 times 1 divided by 1 divided by, you're just in order hitting multiply, multiply, divide, 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 and you get the answer. Does that make sense? You'll be able to do things faster, and it works. You can test it. Okay. Oh, a big number. Okay, well, okay, so we've got 0.0076, thank you. And what's my units? Liters, because that's all that's left, right? Okay, I didn't do it in red for any special reason, then that's what the pen was at, looking at stuff. All right, so that's what we got here. And that seems about right, because I'm dividing 6 by 1,000, and 1, 2, 3 for 1,000. I think it seems right to me. Okay, so I just did that mental check of, does this answer seem right based on kind of the numbers that are there? Always try and do those. It'll save you sometimes. Questions? Yes?
Can you repeat after you just canceled out the grams and the milliliters? What was the next step after that?
Well, the next step after we canceled everything is I put it into my calculator. Okay, and what I would have done is I would have taken 6. I'll just ignore the ones. I would have taken the 6 and I would have divided by this, and then I would have pressed the divide button on my calculator and this number, and then press the divide button again because I'm still on the bottom, and divide by that number. Does that make sense? So this divided by that gives me that. Question? Other questions? Okay. Great. So we'll do one more of these. Why was that 2 significant figures? Because this has 2 significant figures in it, right? And all we did was multiply and divide. All right. Since we're short on time, I'm going to do another ethanol problem like that. Let's say if I have 9.97 liters of ethanol, how many grams does that weigh? Okay, and I'm going to remind you, from our previous problem that we had 1 milliliter is equal to 0.789 grams. okay? And we know that 1 liter is equal to 1,000 milliliters. Those are the conversion factors you're going to need.
Put your unit on it, and you're not gonna get anything else in the bottom here, so go ahead and multiply times the conversion factor. What is conversion factor has liters? Right, so now put it in the correct thing on the top and bottom such that the units cancel, so liters in this case. So now let's look at this. So that you have liters on the top and you have liters on the top. So the liters cancel. What's that? And you have to have a liters on the top and a liters on the bottom. Liters divided by liters, but then they cancel. So that tells you that you need to flip this. The liters on the bottom. Correct. With the milliliters, and then divide by the liters.
Okay, sorry to cut you guys short on time to work this one. There will be practice problems for this in your homework. Let's go ahead and do the answer here. Outside of those of you that have a calculator can maybe calculate your answers. You want to bring a calculator. You're certainly going to want a calculator for the quiz. Well, yes, because there'll be some, I'm not going to, I may hit you with a simple problem for these for the quiz. Not this most complex one at the end, but there's going to be that significant figure calculation stuff. So don't get ready to leave yet. We still have 2 whole minutes for me to work this for you. We start out with the given is 9.97 liters, right? It's not a conversion factor. It's something we measured. I measured how many liters of ethanol I had. And then I need a conversion factor that's going to get me from liters to milliliters so that I can use my other conversion factor to get from milliliters to grams, right? And grams is what I'm looking for my answer. And so when I look at this, I've got 1 liter equals 1,000 milliliters. Which thing goes on top? The 1,000 milliliters. And that's because I need my liters to cancel. I need a liters on the top and a liters on the bottom for them to cancel. So liters on the top, liters on the bottom, they cancel. So then I need another conversion factor, which is my milliliters to grams, right? I'm trying to solve for grams. So I'm going to go ahead and look at this, and I've got milliliters, 1 milliliter equals 0.789 grams. What goes on top? Yep, 0.789 grams. And 1 milliliter goes on the bottom because that way I have a milliliter on the top and a milliliter on the bottom. Milliliters cancels milliliters. And then I can put that into my calculator. And the way this would work in my calculator is I would multiply 9.97 times 1,000 times 0.78, right? And that would give me my answer. I could divide by 1 twice if I want as well, but divided by what? The ones don't do anything. So what do people get for an answer there? Somebody want to share?
7,866.30.
I heard this, so I'll take it. So 7,000, what was it?
866.30.
66.3 grams. How many significant figures should that have? 3, right? Because this will count this as 3. It's probably known better than that. And this is also 3. Okay? So correct significant figures would be this. All right? Great. You guys have a great couple days, and I'll see you on Friday. Remember that, come up and tell me right now if you'd like to meet today for help. Otherwise, there's the help session on Thursday evening at 7.